In this video, I'm going to demonstrate the leg assembly. You still want to step through your book step by step, reading each line carefully and making sure you understand what the instructions say, and let this video serve as kind of a backup to what the text says. So the first thing you want to do is identify any defects on your part. So make sure you know which side has the defect and which side, when assembled, will be on the outside of the product. So in this case, I want to make sure this part is not being seen. You're also going to want to make sure the width of this fits with your finished top assembly. So you must finish your top assembly first, let it dry per the instructions, and then you're going to test fit this with the top assembly before you add the glue block. So read the instructions, follow the steps, refer to the video. Every part, every leg should be wider than the top assembly. We want this to have a nice snug fit. So by design, this should be a 30-second larger than the largest tolerance acceptable for the top's width. So the person who makes this the widest will still be able to make this thing fit in nice and snug. So by design, this is about 1/32 of an inch too wide. It's kind of hard to see. Looks a little heavier than a 30-second here. So this could be slightly smaller than the dimension given in the book. If your part is wide, which it should be, if you're working outside of lab in an open lab time, you're not allowed to use power equipment. You'll have to use the very aggressive 60 grit sandpaper that's next to the Craig machine to remove material from either side. Slowly remove some, test fit, remove some, test fit. If you're doing this in class and you're allowed to use the power equipment, I will demonstrate another method using the radial arm saw. So I've already done that with mine. So this is a demo piece. And then the sandpaper again is by the Craig machine. I've already went through with both of my pieces and cut them to match. So this piece fits in this side. This piece has no defects on either side, doesn't matter, but it fits on this end of my product. Your part very well may be tapered, which mine is. So if I take this piece and put it in the back, it's going to have a lot of play. It's very loose. And then this piece doesn't fit in the front. It's too snug. So when you're fitting this, make sure you fit one leg to one side. Nice, clean, tight joints, no gaps. Same with this side. Pop it in the approximate location it's going to go. Again, nice, clean, tight fit, no gaps. So once I've inspected my material, identified any defects that need to be concealed, I've fit each leg to my top assembly. Now I can start with the actual leg assembly. So I got my defect facing up. Either side on this one looks acceptable. I've got my glue block, and your glue block has sets of holes that are on the inside of the glue block and then sets that are near the outside. So these ones are near the outside, these ones are near the inside. The orientation is critical, so look at the graphic in your book and ensure that you're putting it on here correctly. Again, the orientation does matter. So I'll do one leg at a time. Don't attempt to glue and do everything all at once. So I've got a small scrap piece here. I'm going to use this scrap piece to butt this up against, and then take my glue block in the proper orientation and slide it up against that. I will use that to keep this top surface nice and flush. I'm then going to use a quick clamp to clamp the leg, the glue block and the leg together to make it hold firmly when I drive the screw in. I'm going to position this near the end of the table. Again, I'm going to apply glue to the smaller of the two parts. So my camera died when I was finishing up these parts. So I got both of these done already. I'll go ahead and redo everything on this unfinished part. So where I left off, finding proper orientation, have your block ready, have your clamp ready, and you want to have the screws that you're going to need for the project. There are two types of screws you will have for this project. There's one with a conical shape, which matches the conical countersink on the part. And then we have one that's called a Craig screw or a pocket hole screw with a flat bottom. So the flat bottom screw you do not use in the conical shaped hole that you're about to use here. So conical shaped screw, conical shaped hole, flat bottom screw is for another part later on. I've got my glue open and the opening clean. You want to make sure that you know which side is going to be possibly seen versus which side will never be seen. So this will be butting up against another part. So I'm going to put the glue slightly biased towards that end. Again, when you put the glue out, stay about 1/4 to 1/2 of an inch away from the edges. Shut it when you're done. Use your hand to kind of spread the glue out nice and evenly. Large blobs of glue have a tendency to squirt out more. When it's spread out nice and thin like this, it doesn't have that tendency to squeeze out as much. So we usually spread out the glue. If you put too much, you can just start wiping it off on your paper towel, and make sure you keep your paper towel clean, or clean and damp. So I can remove a little extra. This piece is ready. Again, my paper towel's a little too dry at this point. So I've cleaned off all the glue residue from my hands. I'm going to make sure I'm putting it down in the proper orientation. I'm going to pinch my little support block up to my product, to my leg, and I'm just going to drop this in place. You want to avoid shifting and sliding this around, or you'll squeeze glue out onto the ends. So now it's held firm. It's flush up against the top. Both pieces are flush together. I'm going to use one of these quick clamps to clamp it down. This doesn't have as much force as the bar clamps, so this, you're able to rotate that and get a little more force. But these can put down enough force for what we need here. When you're using this, you want to make sure it's 90 degrees to the part you're going to be clamping. If you hold it kicked inward or canted outward like this, it won't clamp the part correctly. It'll shift the parts as the clamp starts to tighten up. So as you start to tighten up and the clamp is leaning inward, it's going to straighten up and straighten up and straighten up until the top and bottom of the clamp are flush together when it closes, and it's going to shift your parts as it moves. So you want to make sure you're holding this 90 degrees to the part you're going to be clamping. So I'm going to open it up. I'm going to bring it down pretty close, and I'm going to gently put a little bit of pressure on it, and then check it and make sure it still feels pretty flush. And then I'm going to keep squeezing these two blocks together, and then put the final bit of pressure on there. And then again, you can take this off and make sure nothing is shifted. And sometimes it will shift even if you hold it at 90 degrees. So you really want to double check this is a nice flush surface right here. So I've got everything clamped. It's nice and tight. There's glue on there. Now I can take my standard wood screw and I'll drive these in. This screw has a number 2 Phillips head on it. This is a number 6 screw, has a number 2 Phillips head. The drivers that I give you in the cabinet are the correct size. So this is a number 2 Phillips, and it will fit this part. You can use either the screwdriver, or you can use the hand drill with the bit in there. So first, I'll show it with the screwdriver. Most people have better luck with the screwdriver. You have a little more control. The drill, some people don't quite handle as well. I'm going to drop my screw in, and then again, I'm going to use my palm, and I'm going to apply a lot of downward pressure as I rotate and twist the screw. So if you don't push down firmly, you're going to strip the head of the screw out. So pushing with my palm, with my body weight, rotate, release, rotate, and then release, and just put a lot of pressure down and drive the screw until it gets all the way to the bottom. As soon as you feel it hit the bottom, stop driving it downward. So now that it's firmly against the bottom, if I keep driving it, it'll actually act like a drill bit, and it'll make a hole in this piece, and it won't be holding them together. It'll just be free floating. So that's all the way down. And then for this one, I'm going to use the drill. Again, drop my screw in place. When you're using the drill, we first want to set the speed. So this is slow, this is fast. So it's much easier for a beginner to use it on the slower speed. And then we want to adjust the torque setting. So if I put it all the way down here on 1, I can use just my fingers and very easily stop the drill. If I go up to 8, again, it's a little harder, it's kind of moving me. Now if I go up to around 15, I can no longer hold it with just 2 fingers, but my whole hand, again, I can stop it from rotating. The higher up you go, the stronger it becomes, the more you have to stop it, and then the drill setting is 100% power from the motor to the drill head. So this you cannot stop. If you try to hold it, it will just keep spinning. So I'm going to lower the torque setting to about 4. Put the drill into the screwdriver, or the screw, and then I'm going to put my palm on the back and I'm going to drop my body weight on my shoulder and drive the screw. And at the bottom, you can hear it stop moving. So I know it's good.